So now here we are at problem 24, and it says that there's a flagpole that is 15 feet high, and using a clinometer, Tamara measures an angle of 11.3 to the top of the pole, and she's 62 inches tall. How far is the flagpole? How far from the flagpole is Tamara standing? Okay, that makes better sense. Okay. Well, first, there's no diagram, so let's go ahead and let's draw the ground. I'm going to use a black highlighter for that. And there's this flagpole. So, okay, so here's the flag. And let's see. The flagpole is 15 feet high. Okay, so we definitely know that this guy from here all the way down to the ground. So let me see if I can do this here, because that's at an odd angle, so I'm going to move my pad a little bit closer here. You know what? Grab a ruler and much better, much better. That's the straight line that I was looking for. So we know from this red part to this whole part right here is 15 feet. So we know 15. And then we know using a kilometer, Tamara's measuring 11.3. Well, okay, so we need Tamara. Let's put Tamara right here. Yay. Now, Tamara is looking at the flagpole, so and then it tells us that she's 62 inches tall. So this is where, when they're measuring the height, they're basically saying that they want you to believe that this part right here is basically Tamara's entire height. So they're telling you that this is 62 inches. Now, I'm noticing something here. Remember, this 15 over here was in feet. Tamara's in inches. So that means it's probably going to be a good idea to go ahead and cross this 15 feet out and convert it into inches. So if I do 12 times 15, I get 180. So I'm going to rewrite this as 180 inches. And that's going to help us out a little bit in a moment. But when I start looking at this picture, I start to see that there's this possibility of making a triangle. When I have Tamara look straight ahead, you can now see that there's a green triangle that I'm about to highlight that looks kind of like, oh, I said I would highlight it in green, but it looks kind of like this right here. Okay, well, if I knew an angle in this triangle, that would be great, because I already know that this is a right angle. Again, okay, so that is a right angle. Well, it tells you that using the clinometer, this clinometer is 11.3. Well, since it's Tamara that's using it, that means that this corner right here is what they're measuring when they say 11.3. So now we can say, oh, what is it that they want us to figure out? Okay, well, what they want us to figure out is how far away Tamara is from the flagpole. So that's this entire side right here. So I'm going to highlight that in red, since that's a sign of what we want. We want this. But the problem is I don't have any numbers on the hypotenuse or this side. But here's what I do know. I know that this entire red line is 180. But this part, which is some of it, is 62. So if I take this 180 and subtract the 62, it's going to give me just this blue that I'm drawing right here. So that's what I'm about to do. I'm going to say 180 minus the 62, and I get 118. So this blue section right here is 118. I'm going to actually draw that in blue ink. So 118 inches is this blue part. Well, my drawing's getting kind of ugh right now, so I'm going to pop the triangle off, this green triangle, and redraw what it looks like down here. So it looks kind of like this right now. Ooh, I'm going to use a ruler here because that was not the best triangle I've ever drawn. Okay, so we got that, and then we can come over here. Okay, and now we know it's a right triangle. Here's x. You know that this is 11.3, and we said that this was 118. Okay. Now we can actually start talking about this in terms of, okay, here's the hypotenuse because it's across from the box. Here's my corner angle, so opposite and adjacent. Let's see. They give us the opposite. They want us to figure out the adjacent. So opposite and adjacent is good old tangent. So this is a tangent problem of 11.3. So 11.3. Now tangent of an angle is equal to opposite over adjacent. Okay, so let's see here now. If I take this and put it over 1, because it needs to be a fraction to cross multiply, I can say, oh, this tangent 11.3 is going to get multiplied times x, and the 1 is going to, helps if I grab the highlighter, the 1 is going to get multiplied times the 118. Okay, that makes sense. Okay, so we can say 1 times 118 is 118. And then we can say that x times the tangent is just going to be x times the tangent of 11.3. So now I can just say divide by the tangent 11.3 because we want the x by itself, so that means I need to do it over here as well. Hi, Loki. Cross those out because they will cancel. And now I can say, okay, on the calculator, 118 divided by tangent of 11.3, and I get about 591. I'll say that x is approximately 591, but 591 what? Let's see. I'm going to write a sentence because it's a story problem, and so it was Tamara, so I'm going to say Tamara is about, well, if this is inches, I'm going to turn that into feet, so 591 divided by 12, 591 divided by 12, 591 divided by 12, that's 49.25, so 49.25 feet. So let's see. So Tamara is about 49 feet. And how many inches? Well, 12 times 0.25. Oh, that's 3. So 49 feet and 3 inches from the pole.